Hey, what do you say there, math leaguers? This is the week 3 wrap up for our second session. So this is the second to last wrap up video that we're gonna have. I think I'll probably just do a joke separately in a really small video. But I'm gonna split this wrap up into 2 parts. I think I'll go over like the first 8 or 9 questions. There was another error. Good job to one of our mathletes to spot it. And then I'll stop it and then we'll do the second half of the wrap up. Okay, the first question was, there's 5 kids. Their average age is 6 years old. Each kid is a different age, and there's a difference of 2 years in the ages of any 2 consecutive kids. So if there's 6 kids and their average age is, if there's 5 kids and their average age is 6, then they have 30 years total, right? Like if they were all 6, then their average would be 6, and 5 times 6 is 30. But they're just different, right? So one way to do it is to say, let X be the age of the youngest kid. If they say there's a difference of 2 years between every kid, then the next kid would be X plus 2, the next kid would be X plus 4, next kid would be X plus 6, next kid would be X plus 8, and that's all going to add up to 30 years. There's 1, 2, 3, 4, 5 X's, plus 2 and 4 is 6, and 6 is 12, and 8 is 20. 5X plus 20 is 30, subtract 20, so 5X equals 10. X equals 2, that's the youngest kid. It said what's the age of the oldest kid. That's this kid here, the X plus 8. So that kid would be 10 years old. Number 2 is a little tricky. It was asking for the area of this triangle. It gave some points. Like it gave this point like -3, 1, and this point 7, 1. Well, if you think about it, this one's straight across. So from -3 to 7 is a distance of 10. So this distance is 10. Then this point 7, 1 and this point 5, -3. Well, think about it. The vertical distance is from y, right? X and y. Y is 1 and y is -3. So it went down 4. So that's a distance of 4. And here X is 5 and here X is 7. So it went over 2. And then we turn this into like a fake right triangle here so we can find the length of this. 2 squared, which is 4, plus 4 squared, which is 16. 4 plus 16 is 20, equals c squared. So c squared is 20, so c is the square root of 20. I didn't bother to simplify it yet. Same thing over here. We have this point, the x part's -3 and the x part's 5. So we go across 8, right? From -3 to 5 is 8, so this is 8. The y part's 1 and the y part's -3, so the distance down is 4. And then 4 squared, 16, plus 8 squared, 64. 16 and 64 is 80. C squared is 80, so c is the square root of 80. Then, how do you find, look, it's clear that this is the longest, this is a right triangle. This is the hypotenuse, 10. So the base is 20, the base is square root of 80. Square root of 20, the height is square root of 80. If we like spun this triangle. Square root of 20 times square root of 80 is square root of 1600, which is square rootable, which is 40, but it's a triangle, so you got to find area, you got to divide by 2. So that one was 20. That one was hard. Number 3 was just, we've been doing these, triangular numbers, rectangular numbers. We did a heptagonal number. There's a formula for like each special kind of number. The formula for heptagonal numbers is this, whatever the number is, times the quantity 5n minus 3, all over 2. So as for the 9th heptagonal number, so 9, 5 times 9 is 45, 45 minus 3, that's 42, so 9 times 42, and that's all over 2, and we could cancel like that, so it's 9 times 21, which is 189. I'm going to jump to number 5 because there wasn't enough room on this particular whiteboard to show number 4. But on number 5, it said how many 4-digit numbers are both perfect squares and perfect cubes? Well, in order to be both a perfect square and a perfect cube, to be any number where you are something cubed and you're also something squared, you gotta be something to the 6th power, okay? So I just took like some random 6 powers. 3 to the 6th power is not a 4-digit number, it's 729. 4 to the 6th power is 4096. 5 to the 6th power is a 5-digit number, so that's it, just one of them. However, like you might be asking yourself, well, are there like weird numbers like that are squares and cubes that aren't like the same number, squared and cubed? Say like, I don't know, 35 times 35 I think is 1225, I think, right? But what is that? That's 5 times 7 times 5 times 7, so it's a square, but you don't get 3 5s and 3 7s, so it's not a cube. You don't get 3 of anything, and if you did get 3 of something, you'd have to have 3 of the other thing in order to be a perfect cube. You can't have like 7 times 7 times 7 times 2, because that's not a perfect cube. All right? So, that's it. That's the only one. Question number 4. I actually had my old whiteboard from when I did the midweek hints. I did the midweek hints on this. Was about the dice game called craps. What is the probability that you get a 5 and win? This is my work from when I gave an example of getting a 4 and win. So first you have to get a 5. So when you roll 2 dice, there's 36 things that can happen. You could get a 1 and a 1, which is a 2. You could get a 1 and a 2, which is a 3, or you could get a 2 and a 1, which is a 3, etc. There's 36 things that can happen. Out of those 36 things, 4 of them result in a 5. So 4 out of 36, which is 1 out of 9. Okay? Now, once you've rolled a 5, like you have to go back to the rules of the game, then you are trying to get another 5 before getting a 7, and nothing else matters once you've gotten a 5. Getting a 2, getting a 8, doesn't matter. Only 5s and 7s matter once you've established that first point, which would be 5. So, how many numbers matter once the 5 has been established? Well, there's 4 5s in the group, and there's 6 7s, so there's like 10 things that matter, and 4 of them are winners, 4 out of 10, which reduces to 2 out of 5. So, first, get a 5, and in probabilities multiply, and then win. 2 out of 5 chance of winning once that's happened. So you get 2 out of 45. Okay? All right, number 6. It said, number six. It said Jelani took a special math test. He got 3 points for each correct answer, but lost 2 points for each incorrect answer. Again, you guys are smart. Like some of you guys are like 5th, 6th graders. You can grind this out. You could test things. You could make a chart. I would love that. Okay. In this case, though, just to speed things up, a quick little just sort of algebra. This is a systems of equation problem. It said that he took 40 questions. Okay. So we'll call the ones he got right A, and the ones he got wrong B. So the amount he got right plus the amount he got wrong is the amount he took, 40 questions. How many points did he get? Well, he got 3 points times however many he got right, but he got negative 2 points, or minus 2 points, times however many he got wrong. So this equation, 3a minus 2b, is 50. Now, what we can do is we can kind of cross this guy out. We can try to get a common coefficient so that we can eliminate one variable. So I multiplied this equation by 2. So we got 2a plus 2b is 80, right? So this guy's kind of gone now. Okay? Then you can combine these two equations by addition in this case, because that's gonna make the b's go away. Negative 2b plus 2b is nothing. So I got 3a plus 2a is 5a. 50 plus 80 is 130. Divide 130 by 5. A, which is the number you got correct, which is what they were asking, is 26. All right, question 7. This is my guy this week. Found a mistake. I'm gonna be honest with you. Like I said, sometimes I find these problems. Some of them I make up. I found this as an old problem. I think I made it up like years ago for something. And I actually typed the question into AI, and guess what? AI had it wrong. But one of you guys had it right. So sorry about this. This is a mistake. If you had the right answer, send me an email, and we'll try to get you an extra bonus point this week. It was basically just how many Pythagorean triples include the number 24 as one of the sides. Well, let's start breaking it down, right? Like, what are our famous Pythagorean triples? The 3, 4, 5. Well, check it out. We could just times all of those by 8. So then we included 24, right? So this is not 1. It doesn't have a 24 in it, but times 8, times 8, times 8, 24, 32, 40. That would be 1. Also, we could turn that 4 into a 24. So we could times all these by 6. 18, 24, 30. I think I said 30 here, but I meant 40. 18, 24, 30 is another one. So that's 2, just variations of the 3, 4, 5. We know our special 5, 12, 13. Ooh, 12. We could turn that into 24 by doubling all these guys. 10, 24, 26. 8, 15, 17. Ooh, the 8. We could turn that into a 24 by timesing everybody by 3. Now there's another one that's kind of like the next most famous one, which is the 7, 24, 25. So that one kind of stands alone. Now, in this week, in week 4, there's a special formula that says you could take any number and plug it into the special formula and create a Pythagorean triple out of that. So if you did the special formula using 24, actually not using 24, this is not right, this isn't 24. Yeah, if you use the special formula using 24, it's take the number, divide by 2, 12, square it, if it's an even number, square it, 144, and then add 1 and subtract 1. So this is 1. And then this one's kind of an outlier, but if you did a 12, take the number, divide by 2, 6, square it, 36, add 1, 35, 37. Again, that was from this week's, so that's kind of a hint for this week. But then we could double this guy to create this one. So the actual answer was 7. Sorry we had that one wrong, Mr. T makes mistakes all the time. Good job. And let's go ahead and crank out these 2 more questions, so our last video will be shorter. And number 8 was just Victor Wembanyama was 11 for 17 in his free throws. How many out of his next 20 did he need in order to reach at least 80%? So he's going to take 20 more. So I'm like, oh, so he's going to have a total of 37 shots. So what out of 37 is 80%? Well, x divided by 37 is 0.8. We just multiply both sides by 37. X equals 29.6. Okay? So he needs to make a total of at least 29.6, but you can't make a partial free throw, which means he needs to make 30 out of 37 to be 80% or above, right? So if he has 11 already, and he needs to get up to 30,
he needs to make 19 out of his next 20. He needs to be a 95% shooter for that period of time. All right, this one, I know there's formulas that make this go faster. It says, it was like, basically, if it's an odd number, it's the sum of all the odd numbers up to that number. If it's an even number, it's the sum of all the numbers up to that number. So it's like this sum minus this sum. So again, how are we going to find this? Well, remember you can like pair these guys off, right? Like 1 in 2009 is 2010. 3 in 2007 is 2010. 5 in 2005 is 2010. So when you make a pair, it's worth 2010. Okay? Now, how many numbers are there? Well, like if 5 is the third number and you're counting by 2, what you basically do is you take the third number, right? Like divided by 2. So like, oh gosh, I'm saying this wrong, but how many numbers are there? 5 is the third one, counted by 2. So you like add 1 to 5 is 6 and divide by 2. So there's 3 numbers. So you add 1 to 2009, which is 2010, and divide by 2. There's 1,005 numbers. Okay. Now, if there's 1,005 numbers, how many pairs are there? So you got to cut that in half. So 1,005 divided by 2 is 502.5 pairs. Okay, so each pair is worth 2010. So it's 502.5 2010s. This one, if it's even numbers, how many numbers are there? And you're counting by 2, it's just take the biggest number and divide by 2. There's 1,004 numbers. Each pair is worth 2010. So there's 1,004 numbers. There's half of that. There's 502 pairs. So there's 502.5 2010s minus 502 2010s makes half of a 2010, if you kind of say it like that. So that answer is 1,005. Cool? All right, and then we'll do the rest of them in the next video. And the joke will be separate.